Hello, my name is Sam. Today I'll talk about systems of linear equations.
A system of linear equations is a group of two or more linear equations. A solution to a system of linear equations is the value of the variable or variables that is true for all of the equations in the system. There are a few ways to solve a system. The first one I'll show you is by graphing. Graph both all equations in the system on the same coordinate grid. And the intersection is the solution to the system of linear equations. It's pretty simple and quick, but not very accurate. The next method I'll show you is solving by elimination. First, choose a variable to eliminate. You have to eliminate all of the variables until only one of them is left. Let's eliminate x first. To eliminate x, you have to make the coefficients of the x's on both equations opposites to each other. So we'll multiply the first equation by 2. Then we add them together. Simplifying this becomes y is equal to 1. Can you see how I added terms together? 2y plus 1y is equal to 3y. 2x minus 2x is equal to 0x. 4 minus 1 is equal to 3. Now we have y. Let's solve for x. Substitute 1 for y in the first equation, and it becomes 1 is equal to x plus 2. Simplifying this becomes x is equal to negative 1. So the answer is x is equal to negative 1 and y is 1. This time we'll solve by substitution. Solve a variable to substitute. I will choose y. We can see on the first equation y is equal to x plus 2. So substitute x plus 2 for y in the second equation, and becomes x plus 2 is equal to negative 2x minus 1. Simplifying this becomes 3x is equal to negative 3. Simplifying further becomes x is equal to negative 1. Now we have x, we can solve for y. Let's substitute negative 1 for x in the first equation, becoming y is equal to negative 1 plus 2. Simplifying becomes y is equal to 1. This time the answer is also negative 1, 1. Sometimes when trying to solve a system by either elimination or substitution, all variables might cancel out, leaving only numbers. Sometimes the equation is false, like the first one, or maybe true, like the second one. When graphed on a coordinate plane, equations which have false statements have lines that are parallel to each other, and those with true statements have the lines on top of each other or equal. So the ones that are parallel to each other have no solutions because the lines will never intersect with each other. Meanwhile, when the lines lie on top of each other, every single point on the line is the solution to the system of linear equations, which means there are infinitely many solutions to that set. Now I'll explain how adding two linear equations can solve a system of linear equations. Look at the following equation. To solve it, we should first minus 2 from both sides of the equation. Simplifying becomes 2x is equal to 4. Then we should divide both sides by 2, becoming x is equal to 2. Note that we have subtracted 2 from both sides and also divided by 2 from both sides as well. We can't just subtract 2 from one side or subtract 2 from one side and subtract 3 from the other. That just won't work. You need both sides of the equation must be either added, subtracted, multiplied, divided, and etc. by an equal amount. So if y is equal to negative 2, we could add minus 2 to one side and add y to the other side of the equation. This would work. Also, minus 2 from one side and subtracting 4 divided by 2 from the other will also work, but just make sure you keep the parentheses. So when adding two linear equations together, we are essentially adding two equal sides to both sides of the equation. This means we could actually add negative 2x minus 1 to this side and the y to that side. But we would have to reorder the terms and simplify them again. The solution will be the same, but just makes more work. So it's easier to do it this way. Which is also why you should try and choose the equations that have the same form with each other, or change the forms if necessary. Thank you for watching this video. If you would like to watch more math videos, look out for more maths.